This is the screencast for section 1.1, example 9. Grapher failure. Yep, it's true. Your calculator fails. Your calculator will lie to you sometimes. It will have hidden behavior. You will learn more and more about when that is happening as we learn more pre-calculus. At this point, I just want you to be aware that it does happen. Your calculator does mislead you. Grapher failure is when your calculator actually misrepresents what's happening. It technically lies to you. Hidden behavior is when that's actually kind of user error. You have to make sure that you are zoomed in an appropriate window that shows you what's happening in your calculator. And we'll show you a couple examples right here. By the way, grapher failure and hidden behavior are why it is so important to compare your algebraic answer to your graphical answer, which we've been talking about in the last several examples. Example 9, I put in my calculator y equals 3 divided by 2x minus 5. Now, if your calculator has this vertical line right here, that's some of the old software from Texas Instruments. It's no big deal. You just need to know that that vertical line there does not exist. But Ms. Larson, how do I know that doesn't exist? Well, you know that doesn't exist because if you suspect it doesn't exist, no matter what your calculator is showing, if you hit trace and then you hit the value, try x equals 5 halves, which is where that 0 is supposed to be, right? 2 times 5 halves minus 5 should be 0. See how your y value does not have anything with it? That means that value does not exist, so it can't possibly be crossing the x-axis there. It should be, the y value would be 0 then. So in fact, the graph does look like this one without the vertical piece there. The now try problem for example 9 talks about grapher failure. So the first part asks us algebraically to explain why y equals x, y equals x for this more complicated part, y equals x to the 200th to the 1 over 200th, for all x is greater than or equal to 0. So basically, when you have a power to a power, you multiply the two exponents, which simplifies to x to the first. So that should equal y equals x for any x's greater than or equal to 0. In other words, any positive values or equal to 0 to the right side of the y-axis here. So then part B says we'll graph that in the window 0, 1 by 0, 1. And if you haven't figured out what that means yet, this is your, let's see, the window 0, 1 by 0, 1 is going to be your x min, x max, and then y min, y max. So in my calculator, I put, let's see, parentheses x to the, which is the caret, 200th power, arrow to the right, so I have my big parenthesis again. Now I'm going to raise that to the fraction would be alpha y equals number 1 over 200. Now if you don't have the fraction ability on your calculator, like if you have a TI-83 or an older software for the TI-84, you can just put in parentheses 1 divided by 200 for the exponent. Now let's see, I have a specific window I need. My y min is going to be 0, my y max is going to be 1. My x min, y min is going to be 0. My y max is going to be 1. Graph. What? What's going on there? Are there no values there whatsoever? Let's see. Let's trace. 0.5, I see a value. Let's look over here. It says y equals 0. See, what's happening here is your calculator is physically raising every number to the 200th power and then taking whatever it gets and raising that to the 1 over 200th power. It is able to do that up until we get to these numbers are way too small to raise to the 200th power and then to take the 200th root of them. Your calculator cannot calculate those numbers. It just doesn't have that ability. We've reached its maximum capacity. So it drops the values off and pretends like they're not even there. When you and I both know that they are, they exist, it's just your calculator is not physically able of calculating it. So that's our explain of why the grapher failed. Is the graph different from the graph of y equals x? Absolutely. It's missing a lot of values close to 0.